Okay, so if you go to the Lone Star Online, you'll see I submitted a video, somebody else's video about symmetry. So make sure you check that out. It was a really good video that showed you graphs and pictures of what's a function symmetrical on the y-axis, the x-axis, and the origin. So there are two types of functions. There's either even functions or odd functions. An even function is one that's symmetrical over the y-axis, and an odd function is one that's symmetrical over the origin. So note, we're only going to either talk about something that's symmetrical over the y or the origin, because something that's symmetrical over the x-axis is not a function. As you see, it does not pass the vertical line test. So let's look at an even function here. Symmetrical over the y-axis. Of course, you could take, say, this one and graph it and see if it's symmetrical over the y-axis. Does it flip or rotate over that? Or, to do it algebraically, I'm going to replace x with negative x, and it should come out the exact same problem. So let me take my y equals, and in place for x, I'm going to replace that with a negative x and square it. So how many negative x's do we have? Well, we have 2 negative x because they're squaring it. And remember, 2 negatives makes a positive. And that should be 2 of these. So negative x times negative x is x squared. 2 negatives makes a positive. Y equals. So do I get the exact same solution? Yes, I do. So this is an even function. This will be symmetrical over the y-axis. Of course, if we were to graph this here, this is my quadratic function. That looks like a u, like so. And I do see it is symmetrical over the y-axis. All right, now testing to see if something is an odd function or symmetrical over the origin by graphing it is a little tricky because you have to take half of the graph, flip it, and then flip it again and see if it mirrors on the other half. Or you could test it algebraically by replacing y with negative y, x with negative x. So I'm replacing both these with a negative and see if it comes out the exact same. So let me take my y here and add a negative in front of it. Let me take my x and add a negative in front of that x. And let's see if I come out with the exact same problem. So I have 3 negative x's. So negative x times negative x times negative x. 2 of these we know will cancel and become positive. So 2 negatives makes a positive. So it's a positive x squared times negative x. And a positive times a negative is a negative. Negative x squared times x is x cubed. And over here I have negative y. Now I'm not done yet because I want to solve for y. So let me distribute this negative over. Essentially turn that into a positive y, which turns this into a positive x cubed. And do I get the exact same problem? Y equals x cubed? I do. So x cubed is an odd function. It is symmetrical over the origin. Now note when we solve y equals x squared, that was even, correct? Well, let's look at the highest power here, which is just x squared. Squared, 2, is an even number. Cubed is an odd number, odd function. So if you don't want to do the algebra, a really quick test, what's your highest power? 2, is that even or is that odd? That should tell you what kind of function you have as well.